Okay, let's start where we left off in the previous video, number 15, trying to find the arc length. We have the radian measure of the angle, 10 pi over 7. Well, it turns out we can just multiply that radian measure times the radius, which is 5, and that's in centimeters. So our arc length is 50 pi over 7 centimeters. So it's pretty easy once we're given the radian measure of the angle. Don't have to do quite as much as if we were given the degree measure, which is what we're given in number 16. Find the arc length of arc KJ. So we're going to find the arc length here, and I believe we're given a central angle of 260 degrees, but KJ is over here. So we need to subtract that from 360. We get 100 degrees. So the arc length is going to be 100 degrees divided by 360 degrees times 2 pi times our radius, which is 8. It's 8 centimeters. So let's use our calculator to help us out a little bit. We got 100 divided by 360. So that's 0.27 repeating. I'm going to scoot this over for a second here. I think. Let's see if we can do that. Alright, I was able to move the calculator over. Now let's multiply that by 2. So times 2 times 8. Let's see here. So times 2 times 8. And that's pi. Okay, so that's going to be 4.4 repeating pi. Or you could even do, what is that, 4 and 4/11 pi. That's not 4 and 4/11. That's actually 4 and 4/9. So let's get rid of that and fix that really quickly. So 4 and 4/9, let's see, that would be 40 over 9 pi centimeters. So the arc length here is 40 over 9 pi centimeters. You can work on that through your calculator to help you get that fraction as well. Find the volume. We've got a slanted cylinder here, but by Cavalieri's principle, we know that we can just proceed as usual. So the volume equals, well, the volume of a cylinder, right? Pi r squared h. So pi times our radius squared times the height of our cylinder. So we'll plug that into a calculator. That's going to be 25 times 8. So we've got 25 times 8. And that's 200 pi. I'm going to leave it in terms of pi here. So 200 pi feet cubed. You can throw that in a calculator and get the decimal approximation if you'd like. Find the volume of this triangular prism. Well, it's going to be base times height, right? Area of the base times the height. So what's the area of the base here? Well, the area of the base is 1/2 base of the triangle times the height of the triangle. So 1/2 base of the triangle times the height of the triangle times the height of the prism. The height of the prism, or the width here of this prism, is 2. Well, the 2 and the 1/2 cancel out, so we've just got 12 centimeters cubed. Let's move on to our next problems here. Number 19, find the volume of this cone. It's a little slanted, but by, again, Cavalieri's principle, we're going to just proceed as if business is as usual. And a cone, well, to find the volume of a cone, it's basically 1/3 the volume of the cylinder with the same specs, with the same radius, same height. So 1/3 pi times the radius squared times the height. So we're going to go to the calculator in this case. I've got 7 squared, 49 times 13. That's 637. So that would be 637 over 3 pi. 637 over 3. I don't believe 637 is divisible by 3 evenly. No, it's not. It's 212 1/3. I'm just going to say pi, what is that, inches cubed. And again, you can round that into the nearest tenth or hundredth if you'd like. Find r, find the radius, given the volume of this cone is 100 pi inches cubed, or units cubed. So that should really be inches cubed. Let's fix that there. So 100 pi equals, well, we're looking at a cone, 1/3 pi r squared. We don't know r right now, but we do know the height of the cone, and it's 12. I'll clean that up real quick. So that's 12. So times 12. Well, a couple things happen here. We can get rid of the pi's, sort of cancel those out on each side. 1/3 times 12, well, that's going to be 4. So I've got 100 equals 4r squared. What can you do to both sides to isolate r? Well, you can certainly divide by 4 And that works out really nicely. 100 divided by 4 is 25. 25 equals r squared. Well, I'm looking for a positive distance here. I'm looking for the radius. Take the square root of both sides. And r equals 5 inches. 5 inches. Square root of 25, 5. Okay, find the volume. Well, I know, I'm going to go with a different color just to label this guy here. Now this is 18.2 millimeters for the diameter, so that's going to be 9.1 millimeters for the radius. So let's go back to blue just to stay consistent here. If I want the volume of this ball, this sphere, I'm going to go with 4/3 pi r cubed. So that's going to be 4/3 pi times 9.1 cubed. Pull up the calculator again. Well, let's see, 9.1 to the third power, 753 and 571 thousandths. Let's just go ahead and multiply that by 4 and divide by 3 to multiply by our 4/3. I'm just going to leave pi there. So actually, let's just go ahead and multiply by pi. Pi 3.14159. I'm sure there's a pi key on there somewhere, but that'll work. And what's our volume approximately? Our volume is approximately 3,156.55 millimeters cubed. 3,156.55 millimeters cubed. And you could leave that in terms of pi if you wanted. That time I decided to round off to the nearest hundredth. See if we can get through these here before time is up on us. Segments KJ and KL are tangent to the circle, and they're both tangent here. These are congruent segments, okay, just to let you know. Point M lies on circle P, and the measure of angle JML is equal to 60 degrees. What is the measure of angle JKL? Well, the measure of JML, 60 degrees, that's an inscribed angle. We know this arc here is 120 degrees, okay? So if this is 120, well, that means this arc here, if we're looking at major arc, there we go, major arc JML, well, that's 360 minus 20, which, that's all in degrees, that's 240 degrees, right? 240. So the measure of this angle here, exterior to the circle, is going to be 1/2 240 degrees minus 120 degrees. Well, that's 1/2 120. So that angle is actually the same as this angle here. It's 60 degrees. How about that? So what's the measure of angle JKL? Well, it's 60 degrees. Let's move on to the next one. What's the value of x in the figure below? Well, the value of x, figure below, let's see, we've got this angle is 97 degrees. Double it, and that'll give you this arc. This arc here, I can do a better job tracing it. It's a little bit better. Let's double that. Okay, so double 90 is 180, double 7, that's 14, so this is what, 194. Well, to get this arc over here, we would do 360 minus 194. So that angle with vertex on the circle, it measures 1/2 of its intercepted arc. So do some subtraction here. You end up with what, 176 degrees? We'll double check myself here. 360 minus 194, 166 degrees. Oh, excuse me. Math's a little off today. Let's go ahead and fix that really quickly. That's 166 degrees. There we go. So x is 166 degrees. All right, perfect. So 24, we got a vitamin in the shape of a cylinder with 2 hemispheres on each end. What's the volume to the nearest cubic millimeter of this vitamin? I'm going to pause the video real quick, get a little jump start on here. All right, pause the video so I could write this down for you, but the volume of each hemisphere is 4/3 pi r cubed, 3 cubed. We've got 2 hemispheres here, so I'm multiplying by 2. And then I've got the volume of this cylinder. Well, that's pi. The radius is going to be the same here. That's going to be 3 millimeters. And then times the height of the cylinder, which is 8. Plug that into my handy-dandy calculator on Desmos, which will help me out there with putting all that together. And I get 452.39, and I suppose that's millimeters cubed. Yeah. So 452, don't worry about leaving this one in terms of pi, 452.39 millimeters cubed. All right, fantastic. Let's move on down to number 25. Square is inscribed in the circle shown. The side length of the square is 12 feet. So we know that each side of this square 12 feet in length. Write an expression that demonstrates how to calculate the area of the shaded region. Leave your answer in terms of pi. All right, I paused the video and set this one up for us. Well, to find the diameter of the circle, you use the fact that we've got 45, 45, 90 right triangles here. And so side length 12, 12, and well, that's going to be 12 root 2. Cut that in half. 6 root 2 is my radius. So the area of the circle is pi 6 root 2 squared minus, well, the area of the square is 12 squared. It's length times width. Do the subtraction there, and that's going to be my expression that represents the area of the shaded region. They asked us to leave our answer in terms of pi. Now, number 26, the volume of a cone is 300 cubic centimeters, and the height of the cone is 15 centimeters. Find the radius of the cone. Well, 300 is the volume, 1/3 pi, and then we've got r squared times h. I'm going to pause the video here. All right, you see I put a little work there for number 26. Set the volume equal to the volume formula for the cone. Did a little work, 1/3 times 15, well that's 5, divided both sides by 5 pi. And I'm going to take the square root to get the radius. So let's type that into Desmos really quickly. Let's see here, we've got the square root, so square root of 300 divided by 5 pi. Well, that's a radius rounded to the nearest whole number of about 4 units. So that's going to be 4 centimeters. So 4 centimeters rounded to the nearest whole number. Moving on to number 27. A square pyramid has a volume of 486 centimeters cubed. And let's get rid of that there. And a height of 6 centimeters. What's the approximate length of each side of the base? I'm going to pause it real quick. Okay, you see I put a little work there. 486 centimeters cubed equals 1/3 base times height. Well, 1/3 of 6 is 2, so 2 times the area of the base equals 486. Divide by 2 on both sides, and I get 243 equals the area of the base. Well, it's a square pyramid, so if I take the square root, I'm going to get the length of one particular side when I take the square root of the base. So take the square root of 243. I'm going to take this over to Desmos real quick. So square root of 243, and we get 15.588 or 15.6. So about 15.6 centimeters is the approximate length of one side of the base. So we've got those answers there. I want to make sure I highlight them for you. Make sure to study hard for your test. Hopefully this will help you get prepared, and hopefully this video will help you if you get stuck on any of these particular problems. See you soon.